Hey guys, today we're going to code some statistics for the dashboard page in Filament. We'll show the counts of new items with simple graphs, plus a separate user chart. Let's dive into the code. Web Galaxy. Besides the excellent documentation, Filament allows us to explore their demo site, where most of the admin panel features are showcased. For example, there's the dashboard page with stats widgets. There's also a public repository with the code, where we can find how to implement various features. Let's search for the stats widgets. The folder we need is app/filament/widgets. Let's open the customer's chart file, for instance. Here we see an example of fake data and the format in which to pass it. In our project, though, we'll populate it with real data. First, let's look at the Stats Overview widget. It's a general widget with statistic cards. We'll implement cards for new users, products, and brands. In the main getStats method, we return an array of stat objects, which will be formed by the getNewItemStats method for each entity. This method requires one mandatory parameter, the table name, to generate the statistic card. The title is optional, and by default, we'll generate it from the table name. We'll start by populating the stats array with initial data, where the key is a string in the format year-month, and the value is the count of items, initially all set to 0. Next, using the DB facade, we select the count of items, along with the year and month based on the creation date for the last 6 months. We first group by year, then by month, and sort by year followed by month. This will give us grouped items for the last 6 months. Next, we iterate over the grouped items. For each, we generate a key in the year-month format, just like in the stats array, and assign the count of items for that month as the value. This way, months without new items will remain as zeros, while those with new items will be populated with the correct counts. Next, we'll reverse the order of the stats array elements. We'll store the count of items for the current month in new items count, and for the previous month in previous month items count. Using these variables, we'll calculate the percentage increase or decrease in item creation for the current month compared to the previous one. With all the data ready, we'll fill in the stat object. The static make method under the hood simply creates a new instance of the stat class. Then we set the description, icon, an array of stats for the mini chart, color, and return the newly created object. By the way, the process of constructing the stat object is similar to the builder design pattern, like in Eloquent or Laravel's query builders for database interactions. So, by passing the table names, we've successfully generated statistic cards for new users, products, and brands. For the user chart widget, instead of extending the base widget class, as we did for the stats cards, we need to extend the chart widget class. In the heading variable, we set the title. Similarly to the stats widget, we initialize the stats array with data for 12 months this time. We perform a database query and set the data from the results. We get the stats array, where the keys are the months and the values are the item counts. We then assign the keys to labels and the item counts to the dataset's data. Since we seeded the data starting from 6 months ago, the chart starts growing from the 4th month. To display the widgets on the dashboard page, we need to register them in the Filament admin panel provider by adding them to the widgets method. This ensures that the widgets are loaded and shown on the dashboard as intended. The latest update in Laravel 11 introduced the Concurrency facade, which allows us to execute parallel queries. Let's copy an example from the documentation, replace the table names with ours, and test it. All 3 queries to retrieve item counts from different tables will be executed in parallel by separate PHP processes. When we tried to run our functions in parallel, we encountered an error stating that a closure was expected, but we passed a stat object. To fix this, We wrapped our objects in arrow functions, closures. However, we then got another error. Our callbacks couldn't be serialized. This happens because the concurrency facade serializes data before execution in parallel processes. This means concurrency is best suited for simpler cases, such as executing database queries, as shown in the documentation, or making parallel requests to external APIs, but it may not work as smoothly for more complex cases like ours, where non-serializable objects are involved.
Dude, we did a great job. Now stats and parallel queries will be a piece of cake for you. Have a great day. See you around.